Hello students and welcome to Math Weekly number 21. In this Math Weekly we are going to learn to write equivalent algebraic expressions. So let's begin with the big idea of what equivalent expressions are. To begin with, the word equivalent means to be equal in value. Not necessarily to look the same or to be expressed the same way, but to at its root basis have the same exact value. For example, 1 plus 1 and the number 2 are equivalent in value. They're equal. An expression is just a representation of an amount. 1 plus 1 is a representation of an amount. The number 2 is a representation of amount. So when you put that idea together, you get equivalent expressions, two or more expressions that are equal in value. There are two types of expressions, only one of which we're going to focus on today, but the first is numeric expressions. Numeric expressions are representations of an amount made of constants, which are numbers and operations. We also have algebraic expressions, which still contain constants and operations, but at their root basis have at least one variable. To simplify an expression depends on what type of expression you're looking at. If it's a numeric expression, we use the order of operations to simplify the expression. Simplify grouping symbols first, then exponents, then multiplication and division from left to right, and addition and subtraction from left to right. If it's an algebraic expression, we combine like terms to simplify the expression, and that's what we're going to learn to do in today's lesson. So with our focus on equivalent algebraic expressions, we're going to learn to combine like terms to simplify. The rule is that like terms must have the same variable and same exponent. Constants are like terms with only themselves, not with any type of variable. So let's practice the basics. If we have 4x plus 5x, we can combine these together because they both have an x, always looking at the sign in front. So we have 4x plus 5x would make 9x. Similarly, we can combine negative 2y and positive 7y. So we have negative 2y plus 7y. If you owe 2 and you have 7, then you have 5y left. Similarly, these two also have a y, so we can combine those. So if we have 8 and we owe 14, then we owe 6y, negative 6y. Now, let's look at practicing with multiple like terms. Not that all of them are similar, but that some of them are pairs. So 4x is similar to negative 5x because they both have x. If you have 4 and you owe 5, then you owe 1x or negative 1x. These are constants. Positive 10 plus 3 more makes positive 13. This expression is simplified. One term has an x, one term does not, so we cannot put those together. Let's look at another example. 8 minus 2y minus 6y plus 7. Well, let's begin. I always begin left to right. So I have a constant. Are there any other constants in this expression? Positive 7. So 8 plus 7 makes 15. Negative 2y and negative 6y. If you owe 2 and you owe 6, then you owe 8y. And that's simplified because one term has a y and the other one is a constant. Now, we have to do multiplication before we can combine addition and subtraction. Remember, the order of operations says that multiplication comes before addition. So we need to multiply these two together and these two together, left to right, so that we can simplify. So 4 times 5y makes 20y, and 3 times 3y times 2 makes positive 6y. And we can add those together. 20y plus 6y makes 26y. And we can combine those because they both have a y. Let's now look at an example of a multiple choice question. This says, which of the following lists two equivalent expressions? And here are our choices. So we're asked, does x equal x minus 3y plus 3y? Does 6 minus 6 times z equal 0? Does negative 2a plus 2a times 2 equal 0? Or does b minus 4b minus 5b equal 0? Now, as I was reading that, I circled the expressions that are not simplified and underlined the ones that are. So what we're essentially trying to do here is determine if I simplify this non-simplified expression, will it equal x? Or will these ones equal 0? So let's work on these. Let's look at A. A says x minus 3y plus 3y. So if I add 3y and 3y, I get 6y. Is x minus 6y, which cannot be simplified because one has an x and one has a y, we can't put those together, is that the same as x? No. So A is not our answer. So let's look at B. B says 6 minus 6 times z. Well, in the order of operations, we need to do multiplication before we subtract. So 6 times z is 6z, so I have 6 minus 6z, and I cannot put those together because one has a z and one doesn't. So is 6 minus 6 times z equal to 0? No. Okay, let's look at C. C is negative 2a plus 2a times 2. Negative 2a plus 2a gets completed first because it's in parentheses. Negative 2a plus 2a makes 0. If you owe 2 and you have 2, then you don't have any left, but you don't owe any, times 2. And 0 times 2 is 0, which is the same as 0, which makes C our answer. But we always check D just to make sure. So B minus parentheses 4b minus 5b. Start with the parentheses. If you have 4 and you owe 5, then you owe 1, b. So we have b minus negative 1b. When you have subtract the minus sign, that's the same as plus, so b plus b makes 2b, which is not the same as 0. So as you can see, C is the only one that contains a pair of equivalent expressions. So let's summarize what we've learned in Math Weekly 21 about equivalent algebraic expressions. Equivalent means equal in value. Equivalent ratios are representations of the same amount in a different way. To simplify an algebraic expression, combine like terms.